The basic concept of TMS, transcranial magnetic stimulation, is simply induction of an electromagnetic field to the brain by using an electromagnetic coil placed over the scalp and producing a very fast current through this coil, which actually produces this electromagnetic field. The electromagnetic field reaching neural networks or brain cells would cause action potentials, would activate these brain cells, and activation of these brain cells repeatedly can cause long-term changes. What happens with a single pulse, with just one pulse of such electromagnetic field, would be activation of a network for a very short period. If we place such coil over the motor cortex, areas in the brain that control movement, then this single pulse can cause activation of your hand simply by activating these neurons that leads to the muscles of your hand. So a single pulse would cause involuntarily a movement of your hand. Okay, this is just a demonstration of what happens with a single pulse. When you repeatedly induce such pulses to neural networks, you can change the connectivity between the cells in the brain and actually change the whole activity of the network. With deep TMS, we use unique shapes of electromagnetic coils that allow penetration into much deeper brain areas. This is done by a summation of electromagnetic field over the scalp and minimization of non-tangential elements of the coil. The shape of the coil is quite complicated, but it allows eventually stimulation of larger volume and also deeper areas in the brain. Why is this important? The main issue is that when you want to affect different brain diseases, you want to change the connectivity or change the neural network in the relevant areas of the brain that are associated with the pathological condition. So these larger, special, unique deep TMS coils allow this penetration of effective stimulation into much deeper and relevant brain regions to several brain-related disorders. We know that in depression, the pathological circuitries are lying deep in the brain, the brain reward system, for example. And therefore, we would like to affect this type of neural networks in the brain. We could reach such networks even with stimulation of superficial regions just by the connectivity between the more superficial regions to these deeper regions. But direct stimulation of the network is more likely to induce a long-lasting and robust change. This is what we actually see in our results when we stimulate these areas with the unique coil that we developed for treating depressive disorders. The rate of remission and response of patients who did not respond to previous treatments, to pharmacological interventions, or suffered from side effects that they could not tolerate are very high. The remission rates are high, the response rates are very high, and I think that this ability to modulate the relevant neural networks and not change the whole neurochemical activity of the body with pharmacological intervention is a very big advantage. We have less side effects and greater efficacy by targeting specifically in the brain the neural networks that are actually in a pathological condition. The future of the field, and we are already doing research in this direction, is to stimulate and monitor the changes in the brain during the stimulation and after the stimulation. So I think that the future of the field is going to be, like in many other fields in medicine, individualized medicine, finding the correct stimulation patterns for the specific patient. I feel proud that our extensive work during the past 15 years brought real change to many people's life, and in several cases we know that it really made a revolution in their life.